After studying the variation of conductivity and molar conductivity with concentration, now let us do the Kohlrausch law. Kohlrausch observed that the molar conductance at infinite dilution, which is also called limiting molar conductivity, follows a certain fixed patterns for the strong electrolytes. And on the basis of this, he gave his law, which is called Kohlrausch law of independent migration of ions. And it states that the molar conductance or molar conductivity at infinite dilution, which is also called limiting molar conductivity of an individual electrolyte is equal to the sum of the limiting molar conductivity of its individual ions. It means what? That if we have to determine the limiting molar conductivity of sodium chloride, definitely it will be equal to the limiting molar conductivity of the individual sodium ion and of the chloride ion, because at infinite dilution each ion behaves independently irrespective of its the other opposite ion and or from the source irrespective of the source, because the interionic distances are so large that the interionic interactions are almost negligible, zero. So each ion behaves individually, independently, and is able to carry the amount of the charge which it can carry towards the respective electrode. That is why the limiting molar conductivity of the individual ion is a constant value. And if we want to find out the molar conductivity of any salt, any electrolyte, we can just simply add the limiting molar conductivity of its individual ions, because at infinite dilution they are the constant values irrespective of the source. It means what? The molar conductivity at infinite dilution of sodium ion will be same whether it is coming from NaCl or NaBr or Na2SO4 or from any other source, because sodium ion's behavior will be independent of any of its source, any of the other ions at infinite dilution. That is why it is called, its limiting conductivity is independent. So that is why this law is called Kohlrausch law of independent migration of ions. Similarly, the chloride will have its own limiting molar conductivity irrespective of its source. So this is what is the basic purposes of this Kohlrausch law, but we use this law in many other different ways. So let us now do the applications of Kohlrausch law.